and welcome to the next talk. Now we're going to learn about unit testing in Jupyter Notebooks using the testbook library. Here to talk about that will be Rohit Sanjay and Matthew Seal. They are the maintainers of testbook. Do you want to each share where you're located? I guess we will start with Matt this time.
Sure. Yeah, I'm in San Jose, California. So we have nice weather right now, unlike most of the U.S. So just a little south of the PyCascades.
And I'm all the way over here in Bangalore, India, and it's pretty early in the morning.
Thank you so much for waking up early and joining us here. Very excited to learn about both of your framework here, this test book. So let's go ahead and kick it off.
Sure.
Thanks. Oh, do we want to, real quick, if you're following along, make sure you downgrade your ipykernel dependency to the not the latest release, the 5.4, because the 5.5 just released. We haven't tested it, so just FYI.
Perfect. Sounds great. Thank you for that info.
Hello, everyone. This is Unit Testing Jupyter Notebooks. Talk about a library called Testbook that myself and Rohit wrote over the summer, and then we've been maintaining since. Give a little info about ourselves. I'm Matthew Seal. I'm a CTO at a startup called Notable. And the Notable startup, we work on Jupyter Notebooks, the SaaS offering. We're pretty early stage, but you can find us online, a little bit of information, and we're basically always hiring, so happy to talk to folks about that afterwards. And Rohit, do you want to intro yourself?
Yeah. Hi, everyone. My name is Rohit. I'm a final year undergraduate at MIT Manipal in India, and I'm also currently an intern at Goldman Sachs here in Bangalore. Right, so Testbook. So Testbook is a unit testing framework for testing code in Jupyter Notebooks. The previous style of testing notebooks involved writing the tests in the notebook itself, or in some cases, you would extract the code out of the notebook and write tests for it normally. But with Testbook, you can now write tests in the conventional way, which is in Python modules, and you can use that to test the code inside Jupyter Notebooks. So it's like the pytest style of testing, or any unit testing framework in Python for that matter. And now that you can test notebooks, it'll help you write maintainable and reliable Jupyter Notebooks, right? So for those of you who are not aware of what a notebook is, it's just a rendered REPL which combines your code, your documentation, and also the results, the execution results. So it's all in one consolidated notebook, or in one consolidated document. And this is useful for things like iterative development and sharing results and integrating various API calls. So here's a simple unit test using Testbook. So let's say you have a function called func in a cell in a notebook, in a Jupyter notebook, which just returns a plus b. So you write a test for it as follows. So you've got a decorator which basically takes in the path to that notebook file, and also you pass in a keyword argument called execute. In this case, it's passed in as true, which means just execute the entire notebook before this test. And in the next line, you've got you got a reference to that func function, and then you assert that func of 1, 2 equal to 3. So if you really squint your eyes at this, you'd see it as a normal test for a function called func, but you wouldn't know that it's actually running in the notebook. So here's another example. So they've got a class called foo. So similarly, you would test this function, test this class where you create a reference to that class, and you instantiate it by passing anything like a string called bar in it, and then you would call bar.say hello, and then assert that it returned what it should. So again, as I said, if you squint your eyes, you would think that you're writing a test for a class in a Python module, but it's actually sitting in a notebook. So here on the left, you have a notebook with just 2 cells, and on the right you have a Python module called test.py, which tests the notebook on the left. And here's how you would run it using pytest, and you get the green, and we're happy, and we all go home. Cool. So now I'll talk about the features of testbook. So as I said earlier, you can write conventional unit tests for Jupyter Notebooks. You don't have to learn a new type of testing to use testbook. We've designed the API in a way that such that it fits into the general notion of unit testing. So it looks like a normal test, you can write tests for notebooks just like how you'd write tests for Python modules. You can execute all or some specific cells before the unit test. So you have that fine-grained control over which cells you want to execute before before your test runs. And you do that by passing, maybe you can pass the cell tag, you can pass the cell index, or you can even say execute equal to true to run the entire notebook in the decorator. Next, yeah. And you can share kernel context across multiple tests. This is more of a feature of pytest than testbook, I would say, because you can share your testbook instance across tests. Maybe you have a couple of cells that are long running, and also maybe you don't want to run them each time your test runs. So maybe you can create a fixture and scope it to module and then share that instance across all tests. You can perform patching of objects in the notebook. So you can patch things like functions or classes in the notebook, and it's useful in situations where maybe you're doing a network request or some file I/O that you don't want to get executed. And so you've got a simple test here which demonstrates patching. So you've got, if you focus on line 3, you've got tb.patch _ main under main.bar, and then you get a mock object for that bar function, and then I can assert that it was called once using that mock object. So injecting code into Jupyter Notebooks. So this is sort of the secret sauce of how everything in testbook works. Everything that I just showed you earlier uses the inject function that we've implemented. Basically, all assertions are injected into notebook, which Matt will be talking about in a couple of minutes. So how all code is injected, and then the results are pulled back out of the Jupyter kernel process. Also, if you need to perform any assertions which are not currently supported by the testbook API, you could just write the code for that assertion in a string, and then you can inject that into the notebook and get the results. So there's no such thing as so you have that control in case the reference objects don't work for you. Next. And this is just an example. So where we inject a variable called data, which is a list, and then we create a reference object to that data, and maybe we after this maybe we run some cells that modify that list, and then we can write the test to see if it was modified correctly. So we just assert data equal to whatever. Testbook works with any unit testing library. So testbook only provides the assertion part of the equation, and this was an intentional design choice because we didn't want you to get tied down with pytest if you were using testbook. So you can use testbook with pytest, unit tests, or nose, or any other, or your own unit testing framework for that matter. Okay, so that was about the features of testbook. And now I'm just going to talk about a few tests that we picked up from the testbook source code. So here we've got 2 methods that just test the patching functionality that we've implemented. So the first test on line 25, it tests that the code that was injected raises an error. So you can use the pytest or raises method to test that whatever code was injected raises an error. And on line 29, you've got a function that patches the listdir function of the OS module and the list directory function, and we patch it to return a particular list, a fake list, and when we assert that it was called, when we assert the value after it was called, which is actually getting called in the notebook, we assert that it's equal to the list that we just passed in, and then we can also assert that assert called once on the mock object that comes off of the patching context manager. And here you can see that pytest works seamlessly with the pytest marks, the pytest parameterize, the skip test, and whatnot. So you've got like a bunch of test cases. The first variable being the var name, which is just the variable. This is a test that we've written for this to test the value, the functionality itself. So what we wanted to do is that we wanted to test that each type of each data type is being picked up properly. So you've got we added a bunch of variables in the notebook, like a dictionary, a list, an integer, a string, and on the right is the value that we had in the notebook, and then this is just a test to test that that it picks up the value exactly, and that it translates it well across the kernel process into the test process. So we just test that notebook.value of that variable name, which what it does is basically it fetches the value from the notebook into the testbook process, and then it asserts it with the expected result, which is the second value in these tuples. Right. And now I'll hand it over to Matt to talk about some of the context behind why we created testbook and other things. Over to you, Matt.
Thanks. Yeah, we wanted to describe a little bit what came into making this sauce. Basically, we wanted to improve the experience for writing quality Jupyter notebooks. They're more than just a tool for experimentation. The traditional use case for notebooks has been really centered around iterating in data science, where you have really expensive operations, and then you need to discover what you need to do with the results to get what you want. And in today's world, though, there's been a lot of work on bringing notebooks to other environments because it's a really convenient way for people to express data operations in general. And the best practices for writing code, there were some limitations. And so one of the goals with writing a lot of the open source software in this space has been reducing those friction points so that people can do what they want to be able to do within the context that's most useful. So in this case, the writing quality Jupyter notebooks shouldn't be any harder than writing quality Python code or quality .NET code or some other framework language. Jupyter notebooks can get very messy. So the code you write for these things, you're doing iteration, you're just trying things, you change some variables. You can end up with what looks like a scratch padded code. And that's oftentimes a common use for notebooks, to do some scratch padding and find what you need to do. And then there's always a step afterwards where if you need to share it with somebody else or have it run periodically, you need to basically adhere some good production habits on top of that. And that can be things like putting things in functions that abstract away complexity, maybe move large chunks of code to libraries if it's shared across many notebooks or many Python or other language contexts. And you generally want to apply test-driven development. You want to have tests for the things that are complex or have different variable inputs to make sure they work. And a common thing too for development is making small and frequent changes once you know what you need to do. So where's tests fit into that? Well, for code you want to share and do that type of operation, just simplifying the code and moving the code doesn't necessarily guarantee that it's going to keep working. It helps because it reduces the complexity of the contract boundary. But what you actually also need to do is make sure that those contract boundaries are well tested for various inputs of different types. And many times it's not to test that it works today the right way. It's to test when your dependencies change, when the data input changes, when something down the road is different, when someone's rerunning it in 6 months, that you have confidence that it's going to run correctly. And in many cases, this is called productionizing your code. So test-driven for Jupyter. Well, in the past, before Testbook, there are a few notebook options out there, or notebook testing options out there. Some of the unit test ones had a lot of trade-offs. more than testbook does. But some common ones that you would see is you would see the integration test, where you just use something like papermill, which we've talked about before, where you could run the whole notebook in a setting and like kind of test it end to end. And that's good for things that are short and simple and sweet. So you could have like, a very linear notebook. Then, papermill is a good way to test the whole operation of that notebook, because it lets you inject some code and it lets you kind of run in different modes, and the whole thing can be yes or no. Before we run unit tests, when you write them in the notebook object itself, it kind of got in the way. Your development code and your testing code ended up in the same place, and so you had to sort of deal with scooting past your test code or hiding it, and then like you had a lot of problems where you want to share it. So one of the motivations of doing testbook was, why don't you write your test the same way for the notebook you do for any other code? You write a test in a separate test file where you do mocks and manipulations, and you don't need to have that inside the same file where your code is. So we took that same philosophy for testbook. And then another option that was out there was you could refactor code out of the notebooks. This is the most common one, actually. A lot of times people will just say, test notebook is only for exploration. Once you're done exploration, you pull the code out, put it someplace else, and execute it. That can work, but it has the trade-off. The trade-off is, if you need to go back to your original code, the code you pulled out now looks different, right? You've reformed it, you've put it someplace else. So if you need to go back and, I need to change something or add to something or fix something, I then have to work in a different medium and a different interface than when I originally developed it, which means it's going to take me longer to figure out what's working or why it has a bug. And I can't go back to my notebook and then easily move forward. It kind of complicates it. So one of the benefits we had a lot was helping make sure you could stay in the notebook where you did your development and your iteration for common things that you don't need to rewrite, then make more things possible without it. So how's this work? Testbook works by creating reference objects that you saw earlier in the code samples. And these reference objects just hold, like what the object is that's in the notebook, so you can do calls against it and inject code. All the attribute accesses and function calls get pushed down into the Jupyter kernel. So even the assertions get pushed down in the Jupyter kernel. And the reason for this was basically that when you do code execution push model, if you do a pull model, the code being pulled back, you have to serialize it. And Jupyter supports code being pushed down, but not like code execution that you can run from a parent process being pulled back out. There's some of that with JavaScript. You can like emit JavaScript objects you could run, but that's not really what you want to target here. So let me talk about a little bit, show you the push down model, what it looks like, and I'll describe why it's done this way. So pretend we don't have testbook pytest, just you have a notebook and you're running it. In this case, you would have a notebook, you have code cell A, you run code cell A. In a very simplified model of what's actually happening is notebook cell A, no matter how you're running your notebook, is some code and interface you're executing. It gets sent over the network to wherever your Jupyter kernel, the Jupyter kernel, by the way, is just that REPL process that accepts code and executes it. It gets sent over the wire to that kernel, and the kernel will execute that code cell. So code cell A here will execute, and then it'll send back the results. So maybe some std out logs, maybe a display message with like a nice rendered graph or something like that. So that's how the kernel operation communication runs. So put testbook in. What testbook is doing is much like when you're running any other module code that's not in a notebook, you want to basically take your test functions and your test mocks and inject them at the right time to kind of circumvent paths to put different inputs in or to prevent you from making requests you don't want to make and things like that. So here you do the test function that you're injecting. It works the same way over the macro boundaries of the Jupyter kernel. From the Jupyter kernel's perspective, it just gets another snippet of code to run. It says, here, run this function. It says, okay, I'll run this function, and then return the results. Now, if I went back and reran code cell B, I would send code cell B. Code cell B has no concept of what ran before it, but from the execution point of view, you did A and then some mock and then B. Well, then when B runs here, it's going to just run its normal code operation as though if it were, nested inside of a module execution independent. Goes over the wire, talks to the kernel, gets back the results. And then finally, the assertion you want to make, you would send the assertion of, hey, that variable that cell B made, what's its value and does it equal this? And you can do the assertion directly there. And then you can get the green and hopefully not the red X on your end results of your execution. So we started actually when we originally wrote this this library, trying to do some pull up, and then you inside the pytest or whatever your test environment execution do the assertions there and do all the operations. But that gets really difficult for the reasons I was talking about earlier. You basically need to serialize, and not everything is JSON serializable. Like if I have let's say a pandas data frame, I can't necessarily pull that pandas data frame across the process boundary. It has to stay in that process boundary or be translated to a different format. And you don't want to test the translate format. You want to test the original object. So because of that reason, we push things to where the data actually is. So who should use Testbook? Well, we said that developers should be referenced in large teams or production settings. What we really mean is anyone who's authoring a notebook who wants to be able to write tests against it. This can be, writing tests for your future self. If you have a project and you got a little bit of code snippets and you just want to make sure you remember how it's going to work in the future, write a couple tests real quick and you can have it in your project right next to your code that's in your notebook. And that basically boils down to if you want to be test driven and kind of recapture some of the best practices they're used elsewhere in the industry, you now have an easier tool to lower the barrier of entry here. And we hope that Testbook lets you do that well. So we talked a little bit about tests that are in the wild. There's a few other libraries now using Testbook. These are some snippets from when we first launched Testbook and did the first releases, and some people that pulled out. I won't go through these specifically, but you can go to the GitHub and kind of see references that link in and some examples to be able to use it. The first uses were in like research. So you're doing things like research and identity, research with like large data sets where they wanted to run and operate against lots and lots of data, and they want to make sure their notebooks were working correctly, and they were using some kind of custom code. This would be a good example where you're able to replace with Testbook. And another example was things with like there's some like grading operations. If you want to do class exams with a notebook and then run a test against it at the end, you can kind of customize how you use Testbook to fit these other needs too.
And here's a real example where Rohit actually did use the Testbook for the use case of doing grading, and he could talk some more about how that worked.
Yep, thanks, Matt. Yeah, so I previously interned at Jovian.ai, and basically Jovian.ai is a company that launches a lot of data science courses, and they've got a large student base. And the first couple of courses they manually evaluated the assignment, so they needed an automated solution. And I suggested that we use Testbook for this automated grading of the assignment notebooks, and it's worked out pretty well. And also, so this is an example of how Testbook can be used, in the industry, and probably even say you're a professor at a university and you want to test the code written in notebooks that your students have submitted. So you can quickly write up a Testbook script for that and evaluate your student submissions. And with that, I'll hand it over back to Matt.
Thanks, Rohit. So roadmap of Testbook. What's coming up? Well, we actually got a lot of the roadmap past what was expected from when this project kind of came to an initial conclusion to get to a stable point. But there's some things we want to keep working on that are kind of in the run. So big things in here are like adding support for code coverage across the notebook files. So you might want to know how many like lines of code in the notebook are covered by tests. And so an easy way to indicate if you've tested everything. And then we also want to be better support for non-Python notebooks. So there's no reason your notebook has to be Python. It's just Python works really naturally. But we love some examples for other languages that have kernels that are popular that might want to use the same framework to write tests against it because their language doesn't have a supported framework. Right. Well, thanks for coming and listening to our talk. I did want to point out some links to some places where you can find out more about Testbook. There's the PyPI project and the Conda for where you can see the builds of the project and the releases. There's the GitHub that you can go to. Drop a star for good karma. It's a good one to put in there. Testbook, please go try it out, use it, make issues. And we're happy to have contributors. If you want to be even, documentation contributions are things we look for and want to have. So please do feel free to jump on there and try to help. And then we have docs on testbook.read the docs. And then overall, the project sits inside of an org called Interact, which writes different notebook projects in the Jupyter space. Thank you, everyone, for coming, and we hope to talk to you all after.
Thank you, Rohit and Matt, for your wonderful talk. I know I need to test more of my code that I put in notebooks, so I'll have to go download this and start using it. Anything else about the current state of the project?
Hi, yeah, actually the project's been doing pretty well in terms of stability. There was some dependency changes, as I said right before the talk at the very beginning, around the ipykernel had a new release for a minor version, and something changed that we haven't gone in and fixed this morning. So I was looking at it, but I didn't quite get fixed before we got to the talk. But other than that, everything's been pretty stable. They've been working pretty well.
Perfect. Yeah, that's wonderful. Maybe someone can help you out tomorrow if you're open to it.
Nice. Yeah, no, definitely.
Hopefully.
We always like having more contributors on the Interact and Jupyter projects. There's surprisingly few number of people keeping that like machinery oiled and running smoothly.
Oh, no, definitely. Well, I'm going to invite you all to step into the Q&A channel. And if anyone has any questions for our speakers, please feel free to follow up there. We're going to have one last pre-recorded talk, and that will be on shipping breaking changes as the most downloadable Python package. So thank you.
Thank you.